we're going to go over Module 2, naming organic molecules that have multiple functioning groups. So what we're going to be going over today are just an introduction to functional groups. What are they and what do they do? Next, we're going to go over the ranking of the functional groups, so how are they prioritized in terms of their naming. Next, we're going to apply that to pharmaceuticals, so we're going to compare the functionality and uses of different drugs as their functional groups differ. And finally, we're going to go through some sample problems to apply the knowledge that we've learned about naming multiple functional groups. So all matter is made up of different simple and complex molecules and compounds. Functional groups are individual atoms or groups of atoms that are attached to the carbon chains or rings of organic molecules, and they give molecules their characteristic functions. So if two molecules have the same functional group, they're likely to have similar properties. So next we'll be going over what the ranking of the functional groups actually is. We're going to start with the highest priority and end off with the lowest priority. The functional group that has the highest priority is carboxylic acid. So as you can see here, the carbon has a double bonded oxygen and an OH group attached to it. And our group on the left side is just the rest of the molecule, and the same applies for the rest of the functional groups. So for carboxylic acid, the suffix is oic acid. So for the second one, it's an ester, which is a double bonded O and a single bonded O attached to the carbon, and it ends in O8. The amide is a double bonded O and an NH2 group attached to the carbon, and it ends in amide. For aldehyde, it is a double bonded O and a H attached to the carbon, and it ends in al. Ketones are just a double bonded oxygen on the carbon, and it can be beside or between any two R groups, and it ends in -one. For alcohol, it's just an OH group attached to any R group, and it ends in -al. Amines are similar to amides, except they do not have the double bonded O, so it's just an NH2 group bonded to any R group, and it ends in amine. Alkenes are a double bond between any two of the carbons in the carbon chain, which changes the suffix to -ene. Similarly with alkynes, it's just a triple bond between any of the two carbons in the chain, and it ends in -ine. For an ether, the suffix is oxy, and it's a single bonded oxygen between any two R groups. The functional group with the lowest priority is alkyl halides. So they actually don't have any suffix, and they are any element from the group 7 of the periodic table, which is halogens. So it's just that element attached to any R group. Functional groups are extremely important in the making and prescribing of pharmaceutical drugs and medicines. So here are some common drugs that are prescribed. First is acetaminophen. So it's used to treat mild to moderate pain, and it reduces fevers. So as you can see on the diagram, the functional groups are hydroxyl and an amide group, which are pretty easily identifiable. For ibuprofen, it is a non-steroidal anti-inflammatory drug that relieves pain from conditions like headaches, muscle pains, and arthritis. And as you can see also on the diagram, it's got a carboxylic acid on the end. And finally, amoxicillin treats bacterial infections, and it stops the growth of bacteria. So it looks a little more complicated than the other two, but if you look closer, you can see it's really just all the functional groups that we already have seen before, so it's easy to identify the name, even though it looks really long. So functional groups allow drug molecules to carry out their necessary effects. Functional groups play a role in water and lipid solubility, the ability of the drug to interact with specific biological targets in the body. They affect the duration of action, so how long the drug lasts for, and the tendency to cause adverse effects or interactions with other drugs. So in this example, you'll be able to see how important functional groups are to pharmaceutical medicine. So functional groups can be altered to enhance a drug by changing its absorption ability, decreasing the adverse effects, and other therapeutic benefits. So on the screen here you can see acyclovir, which is used to treat some types of viruses that cause infections like shingles, chickenpox, and cold sores. It does this by helping to heal sores and decrease pain and itching. However, acyclovir does not absorb well when taken orally, which is due to the hydroxyl group on the end of the drug molecule. So sometimes the OH group is replaced with a valine ester, as you can see on the molecule on the right, valacyclovir, which is the exact same thing, except instead of the OH group, it is now a valine ester. So this makes the drug much more easily absorbed, which increases the function. So just a recap of these molecules' functions. So acyclovir has limited aqueous solubility and low permeability because of its hydroxyl group, which means it is not easily absorbed. So when the valine ester is added, making it become valacyclovir, it has 3 to 5 times more oral bioavailability than acyclovir, which makes it much more effective. Okay, now we're going to go over some sample problems to test our knowledge on naming multiple functional groups. So we start the first example by numbering the carbon chain from the side that will give the lowest number to the highest priority functional group, so that'll be 6 carbons long. Next, we'll identify which functional groups are present. So this molecule has a hydroxyl group, a ketone group, and 2 methyl groups. So the ketone has the highest priority of these groups, so the molecule will have the suffix -one. Since the hydroxy group is on carbon 1, it starts with 1 hydroxy, then 2 methyl groups on carbon 4 and 5. They will be called dimethyl, and the ketones on carbon 2. So the whole name of this molecule is 1-hydroxy 4,5-dimethyl 2-hexanone. This next example will show a molecule that also has a ketone group similar to the last one, except it won't be the highest priority, so we'll be showing how it will be named differently. So we'll start again by numbering the carbon chain. This one is 5 carbons long, so it is a pentane. So here there's a carboxylic acid on carbon 1, a ketone on carbon 2, and a bromine on carbon 3. The alkyl halide group will take the name bromo. Next is the ketone, which will have oxo instead of -one because it is not the highest priority. And it'll end in oic acid because of the carboxylic acid group. So the full name is 3-bromo-2-oxopentanoic acid. The next example I have here is a 7 carbon chain, so it is a heptane. This molecule has an amine group on carbon 2 and methyl groups on carbons 4 and 5. So here the amine group is the highest priority, so it will have that suffix. So this molecule is called 4,5-dimethyl 2-heptanamine. In this last example, it's going to be a 3 carbon chain, so it's a propane. This molecule has a carboxylic acid group on carbon 1, an amine group on carbon 2, and a benzene ring on carbon 3, and since that is the lowest substituent, it'll be a phenyl group here. The highest priority group on this molecule is the carboxylic acid, so it will have the suffix oic acid. Unlike the last example, the amine here is not the highest ranked molecule, so instead of the molecule ending in amine, this will be called amino instead in the name. So naming it in alphabetical order, it will be the amine first, then the phenyl group, then carboxylic acid, so it will be called 2-amino 3-phenyl propanoic acid.